Since the last nugget, we've been going through the creation of a new instance in Amazon AWS, EC2. And we've been kind of explaining the concepts as we go. We got into the wizard, picked the AMI, talked about where to get the AMIs from, creating your own AMIs, the community AMIs, where those all come from. That we even got into the marketplace and so on. But once you pick the AMIs, you get to pick your region, which we did over on the left, and then choose the availability zone, the number of instances. We talked about the pricing. You really think we've talked about a lot. The different kind of pricing models that you can go with. But one of the things that we haven't talked about yet is the instance type. This is it's a fairly direct concept, but with a lot of ramifications. We talked about pricing, which is huge for your bottom line, but if you look at this is everything for your server. This is how many processors it has, how much memory it has, and it doesn't quite work the same. It does, but not quite the same as just going out and buying a big old server to throw at it, because everything's virtual. So that's what we're going to talk about in here. I'm going to talk about the instance type specifications, which is what you just saw in that little drop down, reading them, understanding what they mean, that kind of thing. The biggest, most confusing thing that people get into is what's up with the ECUs, the EC2 computing units, which is Amazon way of measuring processor performance. I really just want to take a slide to dedicate to that. And I'm telling you, by the time we're done with that, you're going to go, oh, okay, now I get it, especially if you've been toying around with it. And then finally, one that a lot of people don't think about is the I/O performance. I'm talking about network and disk access speed. Something big to think about when you're provisioning these guys. When most people get started with AWS, they come straight to the EC2 land, which is where I started this whole nugget, showing you this. And they create an instance, because that's where the action is. They want to see a server actually running in the cloud. So they come up here and they go, okay, let's create an instance. I'm going to choose one. Sounds good. They look over here. They're like, okay, sure, sounds good. They're kind of like just playing around. They hit this drop down. They're like, okay, free. Let's use that. But then they look over here and they get a general feel. They're like, okay, cores, I get that. And then we've got the whatever these are. I'm guessing bigger's better, which they're right. So you go with that, and the amount of memory. They kind of just, well, let's go with this, and they pick the instance. And that's a great way to get started. Fine, let's create the instance, just kick the tires and see how it goes. But there's actually a lot more to the instances than that. There's always a mix of 4 components inside of an instance type. And you're only seeing a portion of it right here. You're seeing the CPU and the memory. But inside of there, you do have the memory. You have the CPU, or processing power, in terms of ECUs. EC2 computing units. We'll talk about those in just a second. Every instance actually includes storage as well. You get some elastic block store that you're able to use that's included as part of that hourly charge that you pay to run the server, which is great. So you don't have to pay, at least to get started, for extra EBS storage. And then finally, you have the I/O performance, which, again, I'm going to talk about this later, which is hugely important in terms of how well your instance runs in the cloud. So the best place to go, once you want to dig beyond the surface, is to look at their documentation, Amazon's documentation on instance types. You'll see that we have the standard instances that are created. We've got small, medium, large, extra large that is out there. And those all fall underneath what I would call the standard. Where most people get started is micro, and they actually have a category for that. They say, oh, by the way, here's your micro instances. Now, the micros are the ones that they include free, or I'll say at least 750 hours free with a new account. So they are kind of the table scraps. Like, everybody's eating at the table and they kind of sweep a couple crumbs off. They go, hey, micro instance, that's for you. Not to say that you can't use them in production. You can. However, do know that you are getting the leftovers when you go with the micro instances, which is why they didn't throw these under the standard. For instance, you look at the memory, you're like, okay, that's not bad. But then you look here, you're like, okay, 2 EC2 compute units. Well, that's good, especially when you look at the small instance, which is actually more costly than the micro, and you go, well, wait a sec. You get 1 here, and you get 2 here. What do you mean? Well, notice that they're saying up to 2. As in, this isn't really guaranteed. EC2's compute units, or ECUs, are really a measure of computing power. They're kind of like, you know what? If we have some leftovers, you could get up to 2 for a short time. then we're going to throttle you back down to kind of just pathetic values. This is not something that you would really want to depend on. And Amazon put it a great way when they said they are well suited for lower throughput applications and websites that require occasional or additional compute cycles periodically. There's the keyword, period. Like, sure, it's a website, doesn't get much action, run it on a micro. That's fine. However, when you start moving into the small, now you're feeling a little more guaranteed. Like, I know I'm getting 1.7 gigs of memory. I know I've got that one ECU dedicated to me. I'm always getting that processor. I've got 160 gigs of EBS storage. That's awesome. So I've got 160 gigs of elastic block store that when my machine's running, it's there. I can shut it down and it's there. It's included in my hourly charge. So that's really good to see. I get a moderate amount of I/O performance. That's a big thing to consider. So what I really want to do is kind of break these down and talk about them. But keep in mind, I want to talk big picture right now. If you're looking for quantifiable, like, this is exactly what I'm getting in terms of hard drive performance, which is directly impacted by I/O, or network performance, or processing power. Looking at Amazon's website, you're going to feel like, I just need something really tangible, which you're not going to get really from Amazon's website. If you Google it, you'll find out hundreds of people have been doing benchmarks, and you can pull some benchmarks that you can depend on. But there's really a lot of virtual side of it. If you really think about Amazon's advice, it works well. They say the best practice is start small, benchmark it, and scale up if necessary. It's the beauty of this model. In a traditional model, if you're moving from 2 cores to 4 cores to 8 cores, you're buying servers. I mean, that's a significant investment. It's not very easy to do. Whereas here, you might say, well, let's give it a try. Let's move into the very large or extra large, processing and memory resources. And at that point, it's fast. Wow, that's great. But can we do on a large? Can we handle medium? Can we kind of just move between them and see what works for your business? And then benchmark it out and move forward from there. Now you'll see that these are all divided. I'm showing you the standard instances, which are right here. But they're actually divided into standard, you got the micro, and then you move into high memory. It's very common when you get into servers that you're running to consume a lot of memory. So if you have that need, you notice that we're still hanging out with a decent amount of processors, 6.5. And then they're saying, but this guy has 17 gigs of memory. This guy has 64 gigs of memory. This one has, did I say 64? I meant 34. This one has 68 gigs of memory. So we're just going down an increasing significant amount of memory, which is great for things like databases, things that need to consume a lot of that memory to work well. You also have high CPU, something where you're churning through a lot of data. And then recently, I'd say the last couple months, these have come about. Cluster computing instances where you've got a bunch of memory, but look at that. Bam! Just tons of processors that you're able to throw at this. And they even do a case study on these guys. And these also include video offloading, where you've got GPUs in addition to CPUs to do a lot of graphics rendering, things like that that you can include in there. And they do some case studies where there's colleges that have put this together to, matter of fact, let me just pull it up. They have, what is this? This is somebody. It doesn't say who it is, but things like molecular modeling, genome analysis, numerical. I mean, when you think about, the SETI project that I talked about earlier, where it just needs a ton of processor, that's where those would come into play. That's not the traditional business that's using those kind of instances. So that's where you can come in here and choose what level of instance you would like to run at. Now, the big thing I want you to understand is those ECUs and the I/O. Now, before I talk about the ECU directly and define what that is, I want to talk about the why behind it. And if you think about it, it really makes sense. Processors have been increasing in speed year over year. You have Moore's Law, you have all kinds of things that says it's going to get faster. But they've kind of reached a wall with the processors. You might remember, this was, I think it was the Pentium 4. I think we were into the range, and I could be wrong. It's been a long time, but we were at like 3.4 gigahertz and things like that, and people were like, man, how much faster can we make this? How much closer can we pack those wires to make this thing faster? And they kind of hit the wall. They're like, we just can't do it. These things get too hot, they melt down. So as we moved into a new realm of technology, Intel and all the AMD processor manufacturers started saying, well, we can't make that one processor faster, so they started splitting it up and saying, okay, we're going to have 2 cores actually running at 1.7 gigahertz or whatever the case, whatever volume it's at, to where now you can combine and get that level. And now we can put multiple processors split into where you get 4 processor machines, all that kind of stuff. And now you got the quad cores where we take these processors and take all these little 1.7 gigahertz or 1.0 or whatever they're rated at and combine that all together, because programs, applications, operating systems are all now geared to be multi-processor compliant, to where they're not just going to peg, well, they shouldn't if they're a well-written application, they're not just going to peg one of those cores completely. They're going to try and distribute the load between multiple cores so that they gain the benefits of the entire processor. So that's where we are. And over time, I mean, just as things progress, you're getting more and more and better physical processors that are out there. That's how things work. Now, let me get to my statement at the top. Everything in AWS is virtual servers, virtual storage, virtual. But there really are physical items behind that. It's not like this, the cloud. If you peel back the cloud, there has to be a physical server somewhere that's running it. And it just wouldn't be fair if somebody provisioned a server and he happened to get, assigned to the brand new server that Amazon just installed. That's, amazing performance, amazing amount of memory, all that kind of stuff, and then someone else signs up and they get the 3-year-old server. So Amazon had to come up with a way of measuring the processing unit and really limiting it to where it's fair for everybody. Everybody gets kind of the same level. So they created the ECU, which stands for EC2 Compute Unit. This is what it's equivalent to: a 1.0 to 1.2 gigahertz 2007 Xeon processor. Okay, so let's put that together. We're not, everybody's like, oh, I want an Intel i5, if they're thinking of a desktop unit, or an Intel Xeon such and such, the latest and greatest that comes out. Really, this kind of generifies, that's a word I just made up, it generifies all of the processing into this kind of generic standard, to where when I say I'm getting an 8 ECU unit, that means I'm getting essentially the equivalent of 8 processors running between 1.0 and 1.2 gigahertz. That's the speed that they're rated at. Now, I'll say in my experience, just about everything's running at 1.2. And then you combine that with the number of cores. So let's look at some examples. I'm going to bring this guy back up here. I clicked the drop down. Well, actually, let me go to the instance types. I just Googled and brought that up. So let's look right here. We've got let's go with a large. A large says I have 4 EC2 units, which are 2 virtual cores, 2 cores, with 2 EC2 compute units each. Okay, so let's factor that all. It's almost like we got to do some math here. So we said 4 ECUs in the large. We know that, let's go with the 1.2. We know that each one of those ECUs is the equivalent of 1.2 gigahertz of processing, but it also said that I get 2 virtual cores, 2 cores. Okay, so I've got 4 ECUs, so let's just multiply that together. I've got 1.2 times 4. That'd be 4.8 gigahertz of processing power that is split between 2 virtual cores. So I take that, divide it by 2 cores, equals 2.4 gigahertz per core. So when I'm thinking of a large server instance, I'm thinking of a dual core processor, each one of them running at 2.4 gigahertz each. Did you follow that? 2.4. It's kind of a complex way to get there, but once you get it, you're like, oh, that kind of makes sense. And, let's look at Matt. Well, let me look at one more before I give you an actual live example. Let's look at the extra large. We've got 8 EC2 units, so that's 4 virtual cores with 2 ECU units each. So same kind of thing. So if I were to take 1.2 gigahertz times 8, we've got 6 carry the 1, 9, right? So 9.6 gigahertz divided by 4 cores. And it's going to give us the same result, which we now have a quad-core processor, which each one of those running at 2.4 gigahertz each. Are you seeing kind of how we can take this EC2 cloudy virtual sort of concept and translate it into something physical? I think the thing that did it for me was when I really started taking this logical concept, these EC2 units, ECU units, and putting them up against a physical server. So what I did, let me just give you this example. I went to the management console. Let me close this down, and I started an instance. It's a large instance. You can see right here. So large, again, going back to the instances, that was our 4 ECUs on 2 cores. So I said, let's start a large instance, and then I remote desktoped into it. I got the credentials and RDP'd in, and we're going to be doing that in just a few. Let me bring it over here. So this is the default. I just said, give me a Windows Server 2008 R2 standard, and Amazon, in all their glory, gave me this nice little background, which is great. They say, here's your instance ID, but look right here, processing power 4 ECUs. I'm like, okay. What does that mean to Windows? Let's look at it from Windows perspective. Click on Start, right-click Computer, and give me the properties. Okay, so Windows is seeing that it's presenting itself as an Intel Xeon CPU 2.4 gigahertz. Okay, great. So give me that in total terms of processor. Let's bring up the Task Manager and just look at the performance. Okay, so we've got right here 2 CPUs. Okay, this is starting to make sense now. Looking at the resource monitor, go down to CPU. I've got 2 CPU. That doesn't really give me a good view. Let's go to this one. 2 CPUs that are running at 2.4 gigahertz a piece. And when I look back at the slide and calculating it, again, the large was 4 ECUs, each one of them 1.2. Multiply that out. There's my 2 divided by the 2 cores. Now it all starts making sense, and that's exactly what Windows is reporting there. So this really took that logical ECU concept and translated it into something quasi-physical for me to understand. The other big piece to understand is the I/O ratings. This is something that's very often overlooked when you're thinking about instance sizes. You might look and say, oh, that's enough memory, that's enough processor, and not even think about what the I/O is. Memory and CPU, those things are quantifiable. It's like you can hold them in your hand. You get them, and it's dedicated to you. For some reason, I don't know why, I think about it like a slab of butter. It's like you come to AWS and say, I want a large instance. They go, okay, you've got those, what did I say, 8 ECUs that are dedicated to you and 6.7 gigabytes of memory or whatever the amount is. It's like they took a big slab of butter and said, and chopped it off. That's yours. Squish it in your hand. Do whatever you want. Matter of fact, you know what? I just made butter. The other night, I made butter. I was at a friend's house. I got to tell you the story. Please hang on. AWS on hold for a second. I just got to tell you the story because it was amazing, and I'm gonna change your life if you've never heard of this. I was at a friend's house. We're eating dinner, and they're really kind of homey, crafty, and they go, here, have some butter, and they're like, we made that yesterday, and I go, you made butter? You just make butter? And they go, yeah, it's easy. Just grab some heavy whipping cream, put it in a jar, and just shake it. I'm like, huh? You just shake heavy whipping cream in a jar and you get butter? They're like, yeah, it takes about half an hour of shaking. Pass it around the family, make it a family night kind of thing. I'm like, no way. So I get home. This is 2 nights ago now. I did this. Now I'm a little too lazy. We have one of those KitchenAid mixers, that just mix themselves. I'm like, let's try that. So my wife picked up some heavy whipping cream. We dumped it in there and just hit go. And I was like, oh, let's go. And so we were just chatting and all that kind of stuff. So if you've ever dealt with whipping cream before, it's kind of like making pies and all that. You kind of go through these phases of you kind of like it gets whippy. That's where you make the pies and all that. But if you keep mixing, like just let it keep going, 15, 20 minutes later, it magically turns to this. It's really weird. Seriously, it's like you'll be watching it, it's creaming, all of a sudden it's like, oh, it's getting a little lumpy, and then boom, it just suddenly becomes butter. It's like you're sitting there going, did that just happen? Really? Is that? And what was funny is I was sitting at my friend's house and they go, oh yeah, all this leftover milk, you just kind of dump that out and save that because that's buttermilk and you can make your pancakes and all that. And I, on the outside, I'm looking at them, I'm like, oh wow, that's really neat. On the inside, I'm like, that's where buttermilk comes from? All this time I was buying this special buttermilk, I'm thinking there's like a unique cow somewhere. They're like, they milk and that's the buttermilk cow. Or I was like, call me an idiot, but I never knew that. So we did that yesterday. So now I have butter. So I can't even transition that back, but man, I'm telling you, do that tonight. Go make some butter. It's amazing. I/O ratings are really about measuring the shared resources, meaning the network and disk. Remember I said there really is something physical to Amazon's world. There's physical servers that are out there running, and you are actually sharing the network as well as disk access. They have each of their physical servers, I'm sure, with mini network cards spliced together into a lag or ether channel configuration, and they're streaming all of that data down there. Well, you're sharing that bandwidth with all the other instances running on that physical server, and they're sharing it with all their instances and all that. So this represents a shared resource. Likewise, you're coming out here to the EBS data store, which is probably a server with a whole bunch of disks, a little SAN, it's a NAS, whatever they have set up as their data store. You're sharing the network access to that device as well as the actual disk time. And Amazon does a great job of trying to share it equally, to where everybody gets a little piece of that shared pie. So you may be looking at your instance going, okay, well, looks like that processor, that memory is fine, and you look at the I/O and you're like, whatever that means, provision, but you're really moving to a lower level of shared access if you need a lot of network or disk access. Big thing about this is, especially when you get into Windows, it's so easy to slip into that page file where you start overrunning your memory resources. It creates a page file on the hard drive and now kind of swaps applications in and out of the page file. That hits your disk like a bag of bricks. It's like, bam, your disk is just getting slammed. Now the problem is you're now eating up all of, let me say this, if Amazon didn't limit it, you're now hammering that EBS storage and causing performance issues for all the other virtual machines that are accessing it. So what they do is they divide it up to where they have kind of like a pie. You've got all of the people that are accessing. So let's say you've got all of these medium instances. Let's just say a whole bunch of medium instances were sharing that access. They would all get a little piece of that pie. Like they get equal resource access. That's what I'm saying right here. Equal shares are given to the instances to where, okay, that instance gets one. Okay, let's transition. Now they get there. Okay, now they get there. Now, of course, it's not like, you're just waiting in line for hours for everybody to get their share. This is all happening very fast behind the scenes. But everybody's getting a little share of their disk access and their network access on the storage and on the network. So when you're looking at I/O, really, it's in terms of low, moderate, high, and very high. And I would say most people, this is for the clusters. They get the 10 gigabit per second Ethernet channels and things like that. Craziness. But most people are using low, moderate, and high. So all of the lows get an equal share. But remember, you're not competing against a whole bunch of lows. You might be a low competing against a high, competing against another high, competing against a medium. So your little lows and your little, here's your micro. They're all just getting tiny bits of network and disk access. So even though the processor may be good for you, and you may say, well, that should work just fine, you may reach a bottleneck when you get to the I/O. So you really have, again, there's no real way of quantifying it without benchmarking it. Give it a try. Now, and I put a little stream here because think of it like a stream to the river or a stream to the ocean. You can only get so much through your channel on I/O. Now, I want to give you a performance tip, which actually came from one of the AWS engineers on RAID 0. You can get a little, if you require heavy disk performance, which a lot of people do, there's a lot of people that need a lot of disk performance, you can get a little bit more by doing some RAID 0 yourself. Meaning I can create an EBS volume, which comes by default with my instance, and say I want a 10 gigabyte EBS volume, to where I'm storing my data on that volume. Well, I can start creating a bunch of EBS volumes. And then within my instance, let's say this is disk 1, disk 2, disk 3, disk 4, et cetera, et cetera, et cetera. You can keep going. Within my instance, let me actually bring my instance back up here. I can then set up a RAID 0, which is considered a stripe set, over all of those drives. Let me go to the manage here. Now I'm just doing this in Windows. You can do this in Linux as well. There we go. Go to the storage. I've got my disk management right here. Now, this is, for instance, one disk. You can see this is one EBS volume of 30 gigabytes. Well, I could go out and add. Hey, let me get my pen here. I could start adding, disk 1, disk 2, disk 3 in Windows, and then in Windows I could highlight all of those guys and click Create a RAID set. and I would set it up for RAID 0. And what RAID 0 does is it stripes all of that data across all those drives. So instead of just getting one drive that you're writing to at a time, you can actually, in this case, write to 4 drives simultaneously, theoretically increasing your performance by 4-fold. And I say in theory, but you got to benchmark it, because not only are you having the disk that you're going against, but the network as well. That being said, there are some very good benchmarks. You can find them on the internet where people have done this and done very well. Keep in mind the risk of this. When you use RAID 0, you are striping bits of your data across a bunch of disks. If one of those EBS volumes go down, and not hoping that they will, but the chance is there that it could go down, you lose that whole set. It's gone. All of your data is gone. So that would be something that you would really want to think through, having redundancy, having replication, that kind of thing, maybe 3-4 different instances doing this, and now you're feeling pretty good. If you lose one of them, hey, I've got 2 or 3 extra backups that I'm failing over to. So that's the idea of I/O that you really have to think through. Great. Well, at this point, you should be able to start putting these pieces together to form what an instance really is from the cloud. Getting that kind of warm, fuzzy feeling of like, okay, I get this. When I hit those next, finish buttons, I'm doing it with kind of an understanding of what's going on behind the scenes. I see what those instance types are. I understand what an ECU is. I know where that's being stored with the ephemeral or EBS storage. I'm understanding where the I/O performance comes in on throttling my hard disk access or my network access from my instances. To where now, instead of just going, okay, yeah, next, oh, look, it's working. Okay, great. We have a server in the cloud. You're really understanding what's happening behind the scenes. Now, there's plenty more to come, plenty more to discuss, but we are getting ready to the point where we can confidently get our instances running. I hope this has been informative for you, and I'd like to thank you for viewing.